Right now, as you sit there, our entire galaxy is being pulled through space towards something we cannot fully see. Something so massive, so far away, and so strange that even the most powerful telescopes on Earth were blind to it for decades. And here is the thing. We are not talking about a black hole. Black holes are extraordinary and terrifying, yes. But what is actually dragging the Milky Way, along with thousands of other galaxies across the universe, is something far bigger, far weirder, and honestly, a little harder to wrap your head around. Stick with me, because what comes next is going to change how you see the universe. You do not need any science background to follow this. Everything here is going to be simple, clear, and grounded in comparisons you can actually picture. And what you are about to learn about where we live and what is happening to us right this moment, it might be one of the strangest things you have ever heard. If you are new here, welcome. Hit that like button, subscribe so you do not miss what comes next, and drop a comment telling me what you want to explore. Let us get into it. To really understand what is pulling our galaxy, we need to build the picture from scratch, and the first piece is the Milky Way itself. Our galaxy is an enormous collection of stars, gas, and dust. Picture a giant cosmic city, roughly 100,000 light-years across. Now, a light-year is not a measure of time. It is a measure of distance. It is how far light travels in one full year. Since light moves at about 186,000 miles per second, one single light-year works out to roughly 6 trillion miles, 6,000 billion miles. And the Milky Way stretches 100,000 of those across. It contains somewhere between 200 and 400 billion stars. Our Sun is just one of them, sitting in a fairly quiet part of the galaxy, about halfway between the center and the outer edge. Something most people never stop to think about. Our galaxy is not sitting still. Nothing in the universe is. The Milky Way is slowly spinning like a vast, dark pinwheel. But it is also moving through space, drifting in a very specific direction, pulled by gravity. And that pull is where our story begins. Gravity is not just the force that keeps your feet on the floor. It works across distances that are almost impossible to imagine. Every object with mass pulls on every other object with mass, no matter how far apart they are. The force gets weaker as the distance grows, but it never reaches zero. This is why the moon pulls on the Earth, and the Earth pulls right back on the moon. It is why the Sun holds all 8 planets in their orbits from hundreds of millions of miles away. And on the scale of the universe, this same invisible thread connects galaxies to other galaxies, groups of galaxies to other groups, entire cosmic regions to entire other regions. The universe is a web of gravitational forces operating on scales so vast they barely seem real. So when I say something is dragging our galaxy through space, I mean something out there has so much mass, such a colossal concentration of matter, that it pulls on our galaxy and everything around us with almost incomprehensible force. And we are responding to that pull by moving toward it, not slowly and not gently. We are moving at roughly 1,400,000 miles per hour. 1.4 million miles every 60 minutes. To put that in perspective, imagine you got in a car and drove toward this thing at 60 miles per hour without ever stopping. Not for sleep, not for food, not for a single second. You just drove straight ahead, around the clock, for every minute of every day. It would still take you over 26,000 years to cover a single light year. The thing pulling us is about 250 million light years away. Those numbers are almost too large to be useful, but the point lands anyway. Something out there is pulling hard enough to drag our entire galaxy at over 1 million miles an hour through the cosmos, and we only figured it out relatively recently. So what is this thing? For most of the 20th century, scientists noticed something deeply puzzling about the motion of galaxies in our part of the universe. When astronomers mapped how nearby galaxies were moving, they kept finding the same strange pattern. Our galaxy, our neighboring galaxies, entire galaxy clusters stretching for hundreds of millions of light years in every direction, All of it seemed to be flowing toward a single point, not spreading out randomly, not moving in different directions. All of it together, heading toward one spot. Like countless rivers, no matter where they start, all flowing toward the same sea. They called it the Great Attractor, and the name alone gives you a sense of how unsettling this discovery felt. Something enormous was out there, pulling on a scale that had never been considered before, and scientists had almost no idea what it was. That is where things get even stranger. When astronomers tried to look directly at the Great Attractor, they found they could not see it. Not because it was hidden by some exotic physics, because our own galaxy was in the way. The Milky Way is a flat disk, and from our position inside it, looking in certain directions means staring through the thickest, dustiest parts of our own galaxy. Thick clouds of gas and billions of stars completely block our view in those directions, the same way a dense fog can make it impossible to see across a road. Astronomers have a name for this region of the sky. They call it the Zone of Avoidance, and the Great Attractor sits almost perfectly behind it, hidden behind our own galaxy's interior, like something pressed against the far side of a wall we cannot see through. For decades, this immense thing that was pulling millions of galaxies through space was invisible to us. Scientists could feel its gravitational effect, the way you might sense a strong wind without being able to see the storm driving it, but they could not observe it directly. Eventually, using radio waves and X-rays, types of light that can pass straight through dust and gas without being blocked, astronomers began to map what was hiding back there. And what they found changed how we understand our place in the cosmos. The Great Attractor is not a single object. It is not one monstrous black hole lurking in the dark. It is not a single giant galaxy. It is a region of space, roughly 250 million light-years from us, where an extraordinary amount of matter is concentrated. Thousands of galaxies, enormous clusters of galaxies, vast clouds of hot gas, and immense quantities of dark matter are all packed together in this area. The combined gravitational pull of all that mass, spread across a region larger than any single mind can picture, is what creates the tug we feel from 250 million light-years away. Astronomers have a word for these colossal concentrations of galaxies: superclusters. A cluster is a group of galaxies held together by gravity, maybe a few dozen or a few hundred galaxies bound together. A supercluster is a group of those clusters, and it can contain tens of thousands of galaxies spread across hundreds of millions of light-years. These are some of the largest structures that exist anywhere in the known universe. And the Great Attractor sits at the gravitational heart of one of them. Think of it as a valley in the landscape of space. Not a physical valley you could hike into, but a gravitational low point where tremendous amounts of matter have gathered over billions of years. Everything in the surrounding region, including us, is very slowly drifting downhill toward it. The story gets significantly bigger from here. In 2014, a team of astronomers made a discovery that reframed everything. Using radio telescope observations, they tracked the motion of thousands of galaxies across a vast stretch of space. By mapping which way everything was flowing, they were able to trace the boundaries of a supercluster so enormous that nobody had fully identified it before. They named it Laniakea, from the Hawaiian words meaning immeasurable heaven. The name is perfect. Laniakea spans roughly 520 million light-years across. It contains about 100,000 galaxies. Our Milky Way is one of them. The Andromeda Galaxy, our nearest large galactic neighbor, is another. Dozens of other galaxy clusters are part of it too. And the Great Attractor? It sits near the gravitational center of Laniakea. The mysterious force that had puzzled scientists for decades turned out to be the heart of the enormous cosmic structure we ourselves are part of. We were always inside this vast thing. We just had not mapped it yet. An analogy that might make this easier to feel. Imagine you are a tiny drop of water on a surface that is very, very gently tilted. The slope is so subtle you cannot see it with your eyes. But over a long time, you slowly drift toward the lowest point, pulled by gravity down that barely perceptible incline. You are not being yanked. You are not rushing. The movement is slow, almost invisible on short timescales, but the direction is unmistakable. That is what is happening to our galaxy. We are drifting, very slowly on any human timescale, down the gravitational landscape of Laniakea toward its center. And I think what follows is the most unsettling part of all, because Laniakea is still not the end of the story. Beyond the Great Attractor, even farther out, there is an even more massive concentration of matter. It is called the Shapley concentration, sometimes called the Shapley Supercluster, named after the astronomer Harlow Shapley. It sits about 650 million light-years away from us, and it is one of the most massive known structures in the nearby universe. Some estimates suggest it holds the equivalent mass of tens of millions of galaxies like our own. And what makes it remarkable, the Shapley concentration is also pulling on us. Some scientists now believe its gravitational influence on our motion may actually be stronger than that of the Great Attractor. The Great Attractor was identified first because it is closer, and the effect was more immediately obvious. But the deeper researchers looked into the data, the more they found an even bigger engine operating from farther out, driving the whole flow. Think about how that is layered. You live in a neighborhood, in a city, in a country, in a continent. Each level contains the previous one and is part of a larger structure. The universe works the same way, just on scales that make an entire continent look like a single atom. Our solar system lives inside a galaxy. Our galaxy belongs to a local group of galaxies. That local group belongs to Laniakea, and Laniakea exists inside a broader cosmic neighborhood that includes the gravitational pull of the Shapley concentration. We are nested inside, nested inside, nested all the way up. Let me be very clear about something. None of this is dangerous. We are not falling into a trap. We are not heading for any catastrophic collision. The distances involved are so inconceivably vast that even at over 1 million miles per hour, nothing significant would change for hundreds of millions or even billions of years. And on timescales that long, the universe itself will look completely different. On the very largest scales, the universe is expanding. Space itself is stretching, and galaxies far enough apart are being pushed away from each other faster and faster all the time. This expansion works against the gravitational pull of the Great Attractor and the Shapley concentration. On large enough scales, over long enough time scales, expansion wins. Even the most massive structures cannot hold everything together forever. So our ultimate cosmic fate is not to be pulled somewhere dangerous. It is to slowly drift apart as the universe stretches beyond any force that can hold it together. But right now, in this current era of the cosmos, gravity still has the upper hand on these local scales. And so, we move. Sit with that for a moment. Right now, you are on a rocky planet orbiting a star at about 67,000 miles per hour. That star is orbiting the center of the Milky Way at roughly 500,000 miles per hour. And our entire galaxy, together with thousands of others inside Laniakea, is streaming toward the Great Attractor and the Shapley concentration at over 1 million miles per hour. All of this is happening simultaneously at this exact moment without pause, and you feel absolutely none of it. The floor beneath you is perfectly still, the air is calm. Nothing in your environment gives any indication that you are inside a galaxy hurtling through the cosmos as part of a vast gravitational flow toward structures so enormous they make our galaxy look like a single grain of sand on an endless beach. And that, I think, is the strangest thing of all. Not that we are in any danger, because we are not, but that we are embedded inside something so vast and so structured and so continuously in motion, and our senses offer us almost none of it. The universe operates at scales that completely bypass human experience. Without science, without mathematics and telescopes and radio observatories built over generations, we would have no idea that any of this was happening. We would look up at a beautiful, peaceful night sky and have no inkling that we are caught up in a cosmic flow of almost incomprehensible scale. The Great Attractor was not discovered by someone gazing at the stars. It took decades of careful, painstaking work. Generations of astronomers tracked the motions of thousands of galaxies across the sky. They built instruments powerful enough to see through our own galaxy's dust. They developed the mathematics to interpret what all that motion meant. It was patient, committed science, carried out over many human lifetimes. And even now, there is far more we do not know than we do. Dark matter, an invisible substance we can detect only through its gravitational effects, appears to make up roughly 27% of all the content in the universe. The Great Attractor and the Shapley concentration are as massive as they are, partly because of enormous, invisible halos of dark matter surrounding them. Take dark matter away, and the gravitational pull would be far weaker. But we still do not know what dark matter actually is. We know it exists because of how galaxies and superclusters behave. We just cannot identify what it is made of. So even our understanding of what is pulling us through space comes with a significant portion of genuine mystery built into it. Black holes feel terrifying because they are local, dramatic, and seem to consume everything nearby. But what is dragging our galaxy is something entirely different. It is not a single thing you could point to on a map of the sky. It is a region, a gravitational landscape, a slow, vast, barely perceptible flow stretching across hundreds of millions of light years, made partly of things we can see and partly of things we cannot yet explain. The next time you are outside on a clear night, and you catch that faint band of the Milky Way stretched across the darkness overhead, remember what you are looking at. You are inside a galaxy. That galaxy belongs to a supercluster over 500 million light-years wide. That supercluster is being pulled by something even larger, even farther away, by forces that have been operating since long before our sun ever formed. All of it is in motion. All of it is connected. And most of it is hidden from plain sight. The universe does not need an audience to keep running. It has been doing all of this across all of these scales for billions of years, whether anyone was watching or not. But when we do take the time to look and to follow the questions all the way out to the edge of what is known, what we find out there is stranger, more layered, and more awe-inspiring than anything we could have imagined on our own. Next time, we are going to explore another one of the cosmos's great hidden mysteries, something that has puzzled scientists for just as long and is every bit as extraordinary. You will not want to miss it. Until then, keep looking up.